Welcome to part 7. Wait, I mean part 8 of Intro to Functions. This is a long section and I think we're finally to the end. Most of you are probably at the point where you're getting it, but if you still want some extra practice, let's just dig right in. We're on H in the examples for finding the domain of a function. Notice there are no fractions and there are no even roots. So you can say that the domain is from negative infinity to infinity. And those are parentheses because you never reach the end points. In I, example I, we have d of x equals 2x squared plus 5 all over the square root of x plus 3. We have now combined fractions and radicals together. So the rules for radicals still apply. You cannot have x plus 3 less than or equal to 0. They have to be greater than or equal to 0. However, you cannot have a denominator equal to 0 because if it's equal to 0, well, it's undefined. So we have a problem with the equal to. We cannot include that when it's a radical in the denominator. And so we even restrict it further and we say x plus 3 must only be greater than 0 because if it equals 0, it's undefined. So that means x can only be greater than negative 3. And if we draw our number line so that we can create our interval, we have negative infinity to infinity. X has to be greater than negative 3. And so pointing to the right, we can only have the interval from negative 3 to the right. And we do not include negative 3. So it's open parenthesis, negative 3 to infinity, close parenthesis. I should probably also say that is the domain. Okay, moving on to the next question. For j, we have f of x is equal to x squared minus 9 over the square root of x squared minus 3x plus 2. We need to check that the radical is even, and it is. It's a square root. That means that x squared minus 3x plus 2 can only be greater than 0. Remember, if it was just a radical, an even root, it would be greater than or equal to, but since it is in the denominator, since it's divided by an even root, we have to only take the greater than, not the greater than or equal to. Now, let's see if we can factor this x squared minus 3x plus 2. I believe this will give me a negative 2 and a negative 1. That should give me a negative 3 in the middle and a positive 2 at the end. I know that this parabola opens upward because the leading coefficient is positive. And so my first point will be at 2 and 1 will be at 1. So this one will be at 1, this first x-intercept, and the other intercept will be at 2, which means that the intervals on which my function can exist will only be open, so they have to be open at 0. So these are open dots. And our interval where this will exist will be to the left of 1 and to the right of 2. But we have to throw out anything that is negative between 1 and 2. So the interval is from negative infinity to 1 union 2 to infinity. That is my domain. For k, we have the square root of x squared minus 3x plus 2 all over x squared minus 9. Let's go ahead and factor the numerator and the denominator. So we will have t of x is equal to the square root of x minus 2 x minus 1. That's in the numerator. And in the denominator, that is a difference of squares, so we will have an x plus 3 and an x minus 3. Remember, in the denominator, we can't have values that will make our denominator 0. So we know that x cannot equal negative 3 and x cannot equal 3. Those two values will make our denominators, or our denominator of t of x, undefined. So the first thing I'm going to do is put holes at negative 3 and at 3, because I know that that cannot happen. Those will be vertical asymptote values for t of x. Now I know my parabola is opening upwards, and I will have x-intercepts for my radicand at 2 and at 1. That means anything between 1 and 2 I can't include. So I can include anything to the left of 1. So we'll put a closed dot at 1, a closed dot at 2. Clearly this number line is to scale. We can have anything to the left of 1, but we cannot include negative 3 because that will be a vertical asymptote. So that just keeps on going except for negative 3. And then we can include anything to the right of 2 except for 3, because that will also create a vertical asymptote. So this is going to be a very interesting graph. And you could even graph this in like Desmos.com and see what it looks like. But for now, we're just worried about where the domain exists. So we have domain values from negative infinity to negative 3, union negative 3 to 1, and I include 1, because remember, you don't include 1 if the radical is in the denominator. In this case, it's in the numerator. There's a break because the parabola, the radicand, is negative between 1 and 2. From 2 to 3, we have values. There's a break at 3 because that's the vertical asymptote from the denominator. And then 3 to infinity. That is my domain. That looks so crazy. That's a tricky one. I would try doing that one over again, just to make sure you understand what's going on. And guess what? We're finally on the last problem. This one is also tricky, so let's factor it. In the numerator, I have x minus 2, x minus 1. In the denominator, I have the square root of x plus 3, x minus 3. And I know I cannot include x cannot be negative 3 and x cannot be positive 3 because those are the vertical asymptotes from the denominator. So if you look at the function above, it's very similar. In the numerator, again, I can have zeros. So the parabola will have endpoints of 1 and 2. Those I can keep. I can have anything to the left or to the right. Left of 1 and to the right of 2, that's fine. In the denominator, I cannot have values that equal -3 and 3. So if I think of the parabola in the denominator, that would be an open dot at -3 and 3. So I can't include those because it will create a vertical asymptote or an undefined function. So all of that to say, if I look at where these two graphs exist, the first one says the numerator tells me, and let me highlight this, the numerator tells me that I can have anything to the left of 1 or to the right of 2. But my denominator says I can only include things to the left of -3 and to the right of 3. Which means I have to throw out some of these values that are included in the numerator. Notice that the only region or interval where both things exist, both things are true, are to the right of 3 and to the left of -3. That will make all our values defined. So we're only going to keep where they overlap. So that would be from -infinity to -3, union 3 to infinity.